Hello, potential energy. So we've just done kinetic energy. Let's do the other sort of energy that we have to do is potential energy. And potential energy is the ability to do work, not necessarily doing work. And so something like a battery has chemical potential energy in that the chemical processes in the battery can be converted into electrical energy. So it has potential energy. A rubber band, the stretched rubber band, has what's called elastic potential energy. You let go of it and it will do work. Trampoline, again, elastic potential energy. And this rock here, which is just about to squash this person and this dog, perhaps, has gravitational potential energy because of its position. And so if it was to roll down, it would be changing that potential energy into kinetic energy or other forms of energy. But in its position, it has potential energy. So if work is done, an object will gain energy. Now the object can gain energy from its position, and that's pretty much what we're talking about in gravitational potential energy. And because it's due to its position relative to gravity, so generally we're also talking about a vertical position. A horizontal position doesn't have a change in gravitational potential energy. A vertical change does have a change in gravitational potential energy. Usually we use EP, but you sometimes see PE used. And the work done is a measure of the change in potential energy, because this is energy, this is joules, and if work is being done by changing an object's position, then it's a change in potential energy, because work is in joules as well. So gravitational potential energy has the formula mgh. So work is equal to force times distance. Now the distance is actually the height, and this is the vertical height that is being raised. And you might recognize that if we change this, we put a bracket around this, okay, mg is actually F, because we have F weight equals mg. Okay, that's we learnt about weight. And so if we're lifting a weight up a height, that height is equal to S, and that's where the S comes from in the work. So it has to be a vertical height. Okay, so if we get rid of that, all you have to remember is gravitational potential energy, or let's say EP equals mgh, and that's on your information sheet. So the work done in joules, force, distance, mass in kilograms, gravity 9.8 meters per second to the minus 2, and the height raised, again raised vertical height. So let's have a look at a couple of examples. Calculate the GPE, gravitational potential energy, don't know why they use that, but they do, of a 20 kilogram box of groceries lifted 0.75 meters to a bench top. So you're lifting a box up onto a bench top. The potential energy, mgh, put in the numbers, 150 joules. Now this textbook uses 10, we would use 9.8. Just reminding you. And so you have these questions here about a brick and a steel ball, and then a little trickier question here. Have a go at it, see if you can get it. It's just a little trickier. You need to think about it a little bit. And you're also going to have a whole lot of kinetic and potential energy questions, because we've done kinetic energy and we've just done potential energy. And they'll be in your workbook. And if we have time, we may do a vertical jump prac if things go well. Alright, in the next video we'll be looking at power. See ya.